So Patrick McCarthy is the Director of Spaceport Operations for Space Florida. He leads their operational programs as the technical point of contact. And he'll tell you a little about what he does there. And he's been in the current position since the inception in 2006 of Space Florida. And he facilitates commercial, educational, civil, military, aerospace. Sounds like everything. I don't know what's missing out. 25 years of experience in all facets of space launch operations at Kennedy Space Center and Cape Canaveral Air Force Station. BS in Aviation Management from Embry-Riddle Aeronautical University. And he's been flying model rockets since 1968. A NAR member since 1972.
Right.
Only 4 years of...
Some indecision.
Yeah.
Thanks, Ryan.
Yeah.
Let's go to applause before I even start. I appreciate that. Well, I want to talk a little bit about, you can't really prognosticate too far in the future with the U.S. space program, because certainly that changes every time there's an election. But let's, about myself, I have been working at Space Florida since 2006. Prior to that, I worked for the range contractor at Cape Canaveral Air Force Station that coordinated all the range instrumentation for every launch that went off from there. So we had a streak of about 130 successful launches where there were no range-related problems. Most rockets get delayed because of weather and technical problems, but none on the range side. So I like to think that my job as a program manager there helped keep that string going. Prior to that, worked at KSC for a little bit on the shuttle launch processing system on the computer side. So I've been doing things out at the Cape, or KSC, which we like to call the Cape Canaveral Spaceport, since 1988. So when I talk Cape Canaveral Spaceport, I mean everything. Cape Canaveral Air Force Station is this side of the river, and KSC is this side, but together it makes up the Cape Canaveral Spaceport, and that's the kind of planning we're doing as an overall operation. In the next 10 years, it's hard to say where things are going to be, because let's think back 10 years ago. It would be now about 2 weeks after the Columbia disaster. So what was going on then? Well, the space shuttle was not flying, and we were dependent on the Russians to get access for U.S. astronauts to the International Space Station. So 10 years later, where are we? Well, the space shuttle is not flying, and we're dependent on the Russians to get access to the International Space Station. So where are we going to be in 10 years? Well, there's a lot of talk, obviously, about doing commercial activity and flying astronauts on SpaceX and some other commercial boosters. So we'll take a look at those. Just a quick overview of what I'm going to touch on. Give you an idea of the history. Most of you are probably familiar, if you have any rocketry experience, you know about the Cape and what's happened there over the years. Talk a little bit about what we're doing as far as spaceport planning goes. So the planning we're doing now is to get ourselves in a position to support what might be happening in 10 years. And then I'm going to talk a little bit about the different ops concepts and philosophies that we're going to see in the next few years. So at the Cape, we've been flying rockets since 1950. Of course, Bumper 8 was the first launch from the Cape. And since then, we've supported almost 3,400 launches. Not quite as many as Baikonur, but we've launched an extremely diverse mix. When you look at some of the other spaceports around the world, they might fly 3 or 4 different kinds of rockets. Cape Canaveral Spaceport has supported like 110 different kinds of vehicles over its lifetime. So we really know how to do a very diverse mix of vehicles from there. Every U.S. crewed flight has flown from the Cape Spaceport. Of course, all the Mercury and Gemini missions went from Cape Canaveral. The Apollo missions and Space Shuttle missions all went from KSC. So all those crewed missions have flown from there, which gives us the legacy, we think, because of the workforce and the knowledge that's at the Cape to support those kinds of things. Feel free to ask questions anytime, of course, too. All right, what drove things of how we built things back in the early days of the Cape? Well, it was always a purpose-built launch complex. You know, we had everything. You had a Blue Scout, which had a very simple rail launch activity. You had a Navajo, you know, the air-breathing upper stage with the liquid fuel booster stage on it. You had Atlases, you had Titan 4s, Titan 3s, and Titan 4s. You had Mercury Atlas. Everything had a different setup and its own launch pad, which resulted in ICBM Road along the Cape. whenever a new program came along, we built a new launch pad for it that was purpose-built for that particular vehicle. Now that was great in the 50s and 60s when we had lots of money to do those things, and we had a mandate to build ICBMs during the Cold War. You know, when a new program came along, we needed something, they just found some empty space on the Cape and they built it. As rockets got bigger, we moved farther north along the coast. These days, we have to look at a lot of different things. I mean, obviously, there's environmental considerations you have to look at. The population around the Cape has grown quite a bit since the 1940s and 50s when they first chose the site. You know, there's probably 1 million people or so in Brevard County that are within 20 miles or so of these launch pads, so you have to be a lot more careful about what we do. So the idea of moving things farther north, away from the populations in Cape Canaveral and Cocoa Beach, or Titusville, you have to take those things into consideration. So that's what we're doing with these kinds of things. The Air Force has put out their new general plan for what they're doing at the Cape. I'm in the middle of working on the Cape Canaveral Spaceport Master Plan with Space Florida, the organization I work for. We're also doing a statewide spaceport system plan, the first one in the country. You know, Florida's the only state that has 2 active spaceports, unless you want to consider, you know, you can consider Vandenberg and Mojave as spaceports, but there are 2, Vandenberg does not really have much of a commercial operation as much as the Cape, and we built one in Cecil Field outside of Jacksonville, which has got an FAA commercial spaceport license. And the state of Florida has designated space as just another mode of transportation. So the Department of Freight, Logistics, and Passenger Operations is developing a statewide plan for how we're going to integrate space into the overall transportation matrix. Now, what's interesting about that? Well, is space just another logistics method? Yes, it is, and apparently we're going to go to space on SD's Mars lander. Now, I had no idea that that logo was going to be used. Those folks came out, you know, they had to find something. Well, we've got a train, we've got a 737, we've got a boat, you know, a generic ship, we've got a truck and a bus. Well, what do we do for space? Well, the folks in Tallahassee went around and looked for interesting logos, and they said, well, let's find the one for space. It's going to look like this. And so they selected a Mars lander, which I thought was interesting. So why do we have to look at all these different modes? Well, at the spaceport, there's a lot of different ways that things come into the Cape to fly. You've got the Delta Mariner, which is a barge, brings the Delta 4 and Atlas 5 vehicles down from Decatur, Alabama, through the Intercoastal Waterway, down Tennessee River into the Intercoastal Waterway, across Lake Okeechobee, up north along the east coast of Florida, and into the Cape where they offload. The solid rocket boosters and other rockets from Utah come in on rail. So all the shuttle boosters and the new boosters for the Space Launch System, the solid boosters, are going to come in via rail across country. Folks like SpaceX bring their vehicle in on a truck. This is a SpaceX Falcon 9 first stage, and that's very long. It's tough to take on the roads. The Atlas 5 boosters come in on this oversized vehicle all the way from Aerojet nearby here in California. They truck those things cross country. Those are the solid boosters. And for some of the other vehicles and satellites and things come in via air. You know, interestingly enough, most of the commercial vehicles come in on the Antonov 124. And it's a Russian aircraft. I think Volga Dnipro, the company that runs it, is sort of it's a Russian-Irish corporation or something that does that. But they rent those out to bring satellites from all across the world into the Cape. So you have to consider all these different modes when you're doing transportation planning. Back to the land use. Remember, we built a different pad for each vehicle type at the Cape. And as the vehicles got bigger and bigger, we moved farther up the coast. You know, we started off here. These were Atlases, relatively small. The bumper pad was down here on the very tip of the Cape. But you have, like, we have 4 Atlas pads, then 3 Titan 1, Titan 2 pads. And then you get off into the Saturn 1B pads at the farther north, and then the Titan 4, and of course the Space Shuttle pads are way up at the far end of the Cape, about as far away from the general populace as you can get. And we also have a skid strip there, a 10,000-foot runway on the Cape, which may or may not be used for commercial activity in the future. It's certainly going to be used for bringing in those payloads that are delivered by air. So one of the things that the Air Force is looking at is breaking up the Cape and Spaceport into area development zones. Things on the south side down near Port Canaveral are going to be for administrative purposes. You're going to keep the skid strip and use that for horizontal operations like the Virgin Galactics or maybe the X-Core Link, some of those other vehicles that take off and land horizontally. You're going to use the larger pads along the coast for the vertical launchers. And then the interesting thing that we've seen, and this is the latest Air Force plan, instead of having all the pads close up to the beach, they're going to move the newer pads back up onto the 500-year floodplain. So they're going to be farther off the coast. You're only going to have 2 or 3 located along here. So instead of having 36, 11, 12, 13, 14, all the way through 20 here on the coast, we're going to have 3 major zones and maybe 2 pads on each with one central processing location. So they're going to be a couple hundred yards farther in off the beach where they're a little bit safer. And things are going to be consolidated more rather than having a processing building 20 miles away and you having to drive your vehicle all the way in there. You're going to put your processing building right next to the pad, say a kilometer or so away. So you can see on here the historic locations like Complex 19 from the Gemini days and Complex 14 from the Mercury Atlas days. They're going to leave those in place, but they're going to build some newer pads farther inland from there. And again, the idea is to keep those things separated so your safety distances are sufficient to protect those other assets. One of the big things we're doing now is repurposing some of the older existing facilities. Excuse me, I do my Marco Rubio invitation every once in a while since I'm from Florida. So the old operations and checkout building at KSC, which was used for the stacking the Apollo spacecraft in the day and then transitioned over to space station payload support. And the state helped put up some money. We had a deal with Lockheed Martin when they won the contract to build the Orion capsule, now the multi-purpose crew vehicle. We cleared that out. We spent several millions of dollars to clear out the old facility, turn the new one into a nice semi-clean processing area, and now we're doing the Orion vehicle assembly right there. And it's the first time that CAPE has supported the actual manufacturing and assembly of spacecraft. In the past, everything came from outside the state somewhere. So, you know, Boeing would make a capsule or a booster in Seattle or in Louisiana, and it all came down to Cape. Well, this is the first opportunity now that we're going to do those things right there. So the entire engineering and manufacturing capability is going to be right inside the Cape Spaceport itself. Redoing some other existing facilities. Back in the late 90s, we flew Titan IVs off of Complex 40. Now, of course, that's been converted over to SpaceX and their Falcon 9. They have a long-term license from the Air Force for Complex 40. And that shows one erect on the pad, and this was their launch from last October. The whole processing concept is entirely different. Titan used to be stacked vertically in a large facility with cranes, put the rocket stack on there, roll it out a little ways, strap the 2 solid boosters on the side, use these railroad cars to roll it out to the pad, stop it on the pad, roll this gigantic structure around it to allow for servicing. This used to be the largest moving structure in the world, and I forget how many hundreds of tons it was, but it was the largest moving structure in the world. That whole gantry with clean room on top used to move and surround the vehicle. SpaceX does things entirely differently. They bring their vehicle in on a truck from California, and it's in a long warehouse, basically. It's not a clean room. It's relatively clean, shop clean kind of area. Stack the stages together horizontally on a strong back, and then you roll this whole mount the vehicle out to the pad, use hydraulic pistons to stand the vehicle up, plug in the umbilicals to the base of the rocket, and then you lower the strong back a little ways, It just tilts back a few degrees, and then you can fuel it and launch from there. The overhead involved with something like that is much, much less than it was with the Titan IV vehicles. One of the other facilities we're redoing is the orbiter processing facilities at KSC. Since the shuttle program shut down, NASA has got tons of facilities that they have no use for because they were strictly built for one purpose on Space Shuttle. So there are dozens and dozens of buildings. One of them, of course, or three of them, were the orbiter processing facilities. And you get a look at what they used to look like with an orbiter inside. It used to be completely surrounded by gantries. This is a picture I took during a tour a couple of years ago. There's a shuttle inside there. And this is the tail end where the engines are. But when that vehicle's in there, it was completely surrounded by gantries, allowing access to every square inch of that vehicle and the insides. So, as well as a clean room, basically a portable clean room, when you were installing a payload. The infrastructure involved in that is incredible. Triply redundant HVAC systems that can give you class 100,000 clean room or so environment, which is super clean. Hypergolic processing for all those nasty propellants that are used in the orbiter maneuvering system engines. All that stuff's coming out. We're paying, we're helping Boeing invest a lot of money into cleaning out the OPFs, and this was taken about a month ago. So all this infrastructure now has been removed and taken out, and in the future it's going to be what they call a clean pad processing concept, where you only have a couple of cranes to move things around, and all the access is going to be from very small work platforms. This shows the Sierra Nevada Dream Chaser, and I'll talk about that a little bit later. But the Boeing CST-100 crew capsule is going to have the same kind of operation. Just small work platforms that can be moved around with forklifts or on air pallets. You don't need a huge amount of infrastructure surrounding your vehicle to give access for your technicians. One of the other things that we're doing is redoing all the launch control centers at KSC. You might recognize from the outside, you recognize the launch control centers, which of course were built for Apollo. Used to have the great big louvers on the windows. Well, they've taken the louvers off and put in hurricane-proof windows now, so they're thicker and a lot nicer, but they don't have the mechanical interfaces for moving those louvers, which were there in case there was a Saturn explosion on the pad. They would snap those louvers shut and protect the launch team inside. You might recognize here's the view from inside. The technicians used to sit on the floor, and they are removing a lot of the consoles there, which you would see on TV. Shuttle used to have about 300 or 400 person support staff for pre-launch activities on the floor of the LCC. Now the idea is to make things a lot more independent. You can literally operate from laptops and standalone PCs, and that's what these setups are now. This is one of the new control centers that have been built where the older launch control center control rooms were. So the idea is you can make those reconfigurable. Anybody can come in. If you're going to be flying a Falcon 9 from there, you're going to be flying an Antares or some other vehicle, you come in with your own launch team, plug in your software, and you can do your pre-launch checkouts and launch activity from there. And when I worked on the shuttle launch processing system, it was Fortran, COBOL, and all those ancient languages, and they used those same languages throughout the life of the shuttle program. So the stuff that was written back in the mid to late 70s when shuttle was being developed was still in use until shuttle stopped flying in 2012.
Really easy now?
I have no idea. I mean, it's all standalone software, but I don't know. I'm not sure what languages they're operating in. All right, so one of the buzzwords that we're starting to hear from NASA and others is multi-use facilities. Because if we remember in the past, we had all those purpose-built things. Well, that had necessitated an awful lot of money and a big upfront investment. The idea now that the Ground Systems Development Office is using the KSC is let's build a facility that many customers can use. You can reconfigure it to whatever customer needs to go in there. So we're going to see a whole bunch of different vehicles flying from the Cape in the next few years. Space Launch System by NASA, maybe, maybe not. It depends on what Congress decides. Atlas V's, Falcons, ATK Liberty, Delta IV, and down to some of the smaller vehicles. Again, the idea is to turn these things into multi-use facilities. Out the launch pads of Complex 39, you know, in the upper left, when it used to be shuttle, you had the big crawler transporter, which would take a shuttle out there, and a very large gantry and support structure around it, including a port in the white room, which swung around over the payload bay of the orbiter. When in the future, when we start doing other ones, they're going to have towers similar to what we had for the Saturn Apollo series. It'll still go out on a mobile launcher. This shows a ATK Liberty vehicle, which they don't have a NASA contract, but they're continuing some development on their own. This is a 4 to 5 segment stack of a shuttle solid with, interestingly enough, a European Ariane upper stage. They take the core vehicle of the Ariane and they put it on top of a shuttle solid. And you come up with a 2-stage solid with liquid one. And the interesting thing about that is the Europeans have been doing a lot of testing to do an air start on this upper stage, because normally that Ariane core is ignited on the ground when it takes off from French Guiana. Space launch system, whatever that ends up being, you know, after sequestration and after Congress gets done telling NASA what they want to do, you're going to see a lot of other, may see some other different vehicles operating from there. But this is going to be, this is 39B. There's going to be a clean pad out there. All this shuttle infrastructure, these towers are gone completely now. And the only thing you have are these 600-foot tall lightning masts. Everything the vehicle needs is going to come out attached to the mobile transporter and the mobile service tower that come out with it. And then it'll get taken out by the crawler transporter, deposited on the pad, you plug it into your commodities like your LOX and hydrogen and your purge gases and things like that, and electrical, and fly from there. But again, anybody could use those. So if you could build a launch mount that's good for a Liberty vehicle, you can build another one that's good for the Space Launch System. So the idea is that different customers can use it when they need it. And not one, you know, one customer doesn't have to pay for the upkeep of the place for the entire time. We're looking to develop some other launch complexes. These are just a couple of conceptual ideas that KSC has been working on in the past few years. One with a vertical processing concept and one with a horizontal processing concept. So this one works sort of like the Atlas V now. You've got a big integration facility where you stack the vehicle and then roll it out on a launch mount to the pad. And then another one where the vehicle is put together horizontally, similar to SpaceX, and then you roll it out with a transporter erector and stand it up on the pad. And the idea here is you've got horizontal processing capability, the vertical processing capability, and they share the commodities, the liquid oxygen, the liquid hydrogen, the other propellants and gases that they need, so that neither one of those customers has to pay all the upkeep. The idea is to spread that cost over several different users so that the non-recurring costs are not so high. What do we have out there now? Well, we're still flying Atlas V, Delta IV, and Falcon 9. In the future, and these are probably going to fly, yeah, we're going to fly 12 or 14 a year at the current plans. Falcon 9 will probably get up to a higher launch rate, but of course they've still got a lot to prove. I mean, they've flown, what, 3 times so far, and I know they have a lot of vehicles or a lot of customers on contract, but it remains to be seen if they can meet their projected flight rates. If they fly once a month, that would be great for the Cape, and we'd love to see that.
Do they have one coming up next month?
Yes, there's one scheduled right now for March 1st, right? It's next week. So what kind of things are we going to see in this new launch vehicle mix? Well, in the background, we've got the SLS, and these are just some comparative size things to show you. You've got a Saturn V, it's sort of a Nova class vehicle. Falcon Heavy, which, you know, I think the first flight is scheduled to go from Vandenberg, but then they've got several missions scheduled to fly from the Cape. Of course, Falcon 9, Delta IVs, Atlas V series. We'll probably see Antares from the Cape. That's the one that Orbital Sciences is developing. That's the competitor to SpaceX for taking cargoes up to the space station. and then several smaller vehicles, and I'll touch on a couple of those in a second too. All right, vertical launch ones. What kind of cool ones are we going to see? Well, probably within the next couple of months, we're going to see Antares fly from Wallops. That's the one that Orbital has a contract to deliver cargo to the space station. Falcon Heavy, sometime in 2014, maybe 2015 from Vandenberg, probably a year or so after that to fly from the Cape. Smaller launch vehicles, we're doing a lot of studies now to fly sounding rockets from the Cape again. It's been several decades since we've done that. We'll see things like Spark, Super Stripey, and there's several other smaller ones as well. One of the coolest projects I'm working on now is the Orion Ascent and Warp mission. And you can call it Little Joe 3. Its purpose is to test the launch escape system for the Orion capsule. So you had Little Joe, which tested the escape systems for Mercury. You had Little Joe 2, which tested them for Apollo. This we can call Little Joe 3. It's a cool vehicle, except the big problem is it has no fins. It's going to be a miserable scale model unless you put clear plastic fins. And there's a lot of judges out there that don't like clear plastic fins on scale models.
Can you do something about that?
We could. Well, I've asked them, I said, do you need any fins on this? And they said no. This is a very interesting vehicle. It starts off, it's about an 18-foot diameter aeroshell because that matches the Orion capsule and its shroud. Underneath here, you've got the first stage of a Peacekeeper missile. And that's the booster to get it off the ground. It's going to fly to about 40,000 feet and near transonic speeds, not quite max Q. And that's when they're going to fire the escape rockets off to pull the capsule away and test the escape system. And the booster is only about 50% done burning by that point. So you're going to have this Peacekeeper booster, which, by the way, has about 150,000 pounds of ballast on top of it, because if you didn't do that, it would push this capsule and escape system way faster than you need to. So a Peacekeeper motor with 150,000 pounds of steel plates sitting on top of it. We put the capsule on top of that. We put these aerodynamic ogive aeroshell around it. And then you put the launch escape rocket, this tractor escape rocket on top of that. You fire the Peacekeeper motor, it gets up to this transonic speed, then they separate the capsule with the escape motor and test that out. And we haven't decided yet what they're going to do with that other 40 seconds or so of the Peacekeeper motor burning. Theoretically, it's supposed to remain stable after that because it's got all that mass up front. But again, it's going to be a blunt body, and they don't think that the thrust vector control on the Peacekeeper is going to be able to keep it pointed in the right direction. So range safety guys are talking about destroying it with explosive charges, or at least opening up the casing immediately after the escape rocket pulls the capsule away. It's going to be a very interesting mission. Right now it's scheduled for the end of 2018, but they're looking at the option of flying that in 2016. I'm in the middle of that because that's going to fly off Complex 46. That's one of the launch pads that Space Florida has license to from the Air Force. We're the operators of that pad, so I'm in the middle of working their facility interface requirements and things like that. Hopefully that won't get canceled or pushed off too much by revisions to the NASA budget. Other vehicles, I talked about the Liberty from ATK. Again, the shuttle solid with a EADS Astrium Vulcane 5 powered liquid fuel rocket on the upper stage. The NASA Space Launch System, again, in whatever configuration that ends up. And right now the plan is to have 4 or 5, I think the latest was 4 shuttle SSMEs in the core, and then it'll have 2 shuttle solids on the outside. And then that'll transition to 2 liquid fuel boosters, which go on the strapline. One of the interesting companies we're working with now, and these folks are out of Mojave, is Maston Space Systems. They're building a reusable suborbital vertical takeoff and landing vehicle. And they've flown it hundreds of times from Mojave. They're looking to come to the Cape. The version we're going to see fly from the Cape is going to have an aeroshell, but it's going to be very similar to this. I mean, it's about 350 pounds or so. I mean, I know that they move it around with like 3 or 4 guys. They pick it off the back of this trailer, pickup truck, set it down, fuel it from drums. It flies with LOX and isopropyl alcohol, I mean, they literally stick a hose in the drum of alcohol and one in the vehicle and hand crank the fuel into it, and then they bring up the locks and pump that in. And the idea is that it can take off vertically, go up to about 400,000 feet, give you a few minutes of microgravity for a couple of pounds of your payloads, and then it'll come back down tail first, and then it gets near the ground, you fire up the rocket engine again, and land under rocket thrust at the same place you took off. Now, the range safety folks at the Cape were very interested in that. I mean, normally they don't like to see rockets come back to the Cape, especially not rockets under rocket thrust. So this one was an interesting exercise to go through with them to get them to buy off on it. But they have. Maston's been approved to fly some low altitude flights, and hopefully we're going to see them from the Cape later this summer. One of the other cool vehicles we're working with is Army Swords, and this is Soldier Warfighter Operationally Responsive Deployer for Space, and I think I got that right. This vehicle is about 80 feet tall, 80 or 90 feet tall. They're still in the middle of their design iterations. It has, actually very interesting, looks sort of like a Saturn 1B, because it's got these tanks that are cored around a central core tank and several smaller tanks around the outside. It's a liquid oxygen and RP-1 vehicle. And their intent is to fly CubeSats up to a 250-kilometer orbit for less than $1 million a shot. And what they want to do is have small satellites on standby, so when you need a capability somewhere, you can pull a satellite off the shelf, an imaging satellite or a communications relay satellite or something like that, get it into orbit within a day or less, so that you've got soldiers deployed somewhere, say in Afghanistan or Iraq, whatever, that needs some comm or some imaging. You can get this satellite up there on very short notice. And the idea is to, if you bring the cost down to $1 million a launch or so, which is relatively inexpensive for space launch, the reaction time is very low, rather than the years it normally takes to get a satellite prepared and into space. The idea is that you've got a sergeant somewhere that needs imaging of what's over the next hill. Well, you can get a satellite up within 8 or 10 hours, perhaps, that'll be overhead, and give them that imaging directly down to a handheld terminal that some soldier is carrying in the field. So the idea there is you don't have to go through that huge bureaucracy of bringing things, from a multi-billion-dollar spy satellite down to the CIA, over to the Pentagon, down to the warfighter command somewhere, and then to a theater command, and then transmit it finally to some link out in the fields where the soldier can see it on his laptop. The idea is that you can get a satellite up there in very short notice, beam the signals directly back to the soldier's laptop or tablet so they can see what's going on. Horizontal launch vehicles. You're going to see a lot of this in the future. Things are getting very interesting here. Most of you have probably heard about Virgin Galactic, and they're going to be flying tourists maybe by the middle of next year or so. They're going to be doing their test flights. Virgin Galactic's the one, and this is a different concept, but they have this twin fuselage aircraft that carries up a rocket-powered vehicle chock full of tourists, 6 or 8 of them at the time. Get up to 40,000 feet, drop the rocket-propelled tourist vehicle, launch that up to 300 and some thousand feet where they get a minute or so of 0G, and then glide back to a landing. What they want to do, and this they're calling Launcher 1, is carry up a booster vehicle underneath that in place of the tourist capsule or the tourist vehicle, and fly satellites from there. I mean, it's sort of like the Pegasus concept that Will talked about earlier, only it's a much smaller size vehicle. On the opposite end of the scale is Stratolaunch, and this one partially bankrolled by Paul Allen. And the idea here is he's taken a couple of 747 size fuselages, and this aircraft is going to be built out at Mojave. They've already built the hangar. At the let's see, when this concept was done, it was still when SpaceX was going to build them a Falcon 5 kind of derivative liquid fuel vehicle that goes underneath, again, to carry this up to about 40,000 feet, drop this rocket-propelled vehicle and let it go on up into orbit. It would be a couple of stages. Since this came out, they've changed from SpaceX to Orbital Sciences, so it looks like it's going to be a solid propellant vehicle instead of liquid propellant one. But again, it's on the order of a Delta II class booster that you're carrying up. This would be the world's largest aircraft, bigger than the Hughes Spruce Goose. And I forget the exact dimensions, but the wingspan is, 350 feet or something like that. Bigger than the A380, bigger than a C5 or an Antonov. And then you hang a Delta II underneath it and carry it up to 40,000 feet. Well, that's pretty impressive. It's going to be neat if they can carry it off. Again, on the small side, we've done some work with starfighters. These are folks that have F-104 fighters that they've refurbished, turned them in. Mostly they do air shows and things and aerial demos, but they're also working with some universities and smaller satellite manufacturers. You're going to hang basically a large model rocket under it, an amateur-sized rocket. Starfighter can go pretty good. You can't quite get to Mach 2 when you have something hanging on it, but you can get up to 50,000 feet plus when you separate this rocket vehicle, and you can get a nanosat or perhaps a microsat size, a kilogram or two into a low Earth orbit. So and you can fly it from